Hello, class. Today we're on Chapter 1, Lesson 4, Division. Now, if two people share a dozen clams so that each one gets the same number, how many will each one get? This, this is such an easy division problem that we know the answer immediately. One way to illustrate it is shown below. Here we go. We have our circles again. And what we're doing is we have a dozen clams, okay? And we're dividing them by 2, so we're breaking out into sets of 2. 1, 2, 3, 4, 5, 6 sets of 2 circles. 12 circles have been separated into groups of 2. One clam for you, one for me, one for you, one for me, and so forth. The answer 6 can be found by counting the number of groups. So if one for you and one for me would turn into 6 for you and 6 for me. The method that some mechanical calculators use to divide is illustrated at the right. The calculator subtracts 2 from 12, 2 from the result, 2 from that result, and so on until it arrives at 0. The number of times 2 has been subtracted is the answer, so it would have been subtracted 6 times. Although this may seem like a peculiar way to divide, it is related to the way that we have been picturing multiplication as repeated addition. The calculator is doing division by repeated subtraction. Division can also be interpreted in terms of multiplication. The answer to the problem of dividing 12 by 2 is the number that must be multiplied by 2 to give 12. Okay, so now we're entering really, I think, into the element that you should focus on. Because I like to call multiplication and division cousins. Similar where we have addition and subtraction. They're sort of like the opposites. You could almost say the same thing of math, of division and multiplication in math. Okay, division can also division can also be interpreted in terms of multiplication. Just to reiterate this, the answer to the problem of dividing 12 by 2 is the number that must be multiplied by 2 to give 12. This interpretation can also be pictured by means of the relationship of the area of a rectangle to its dimensions, as the figure at the right illustrates. So we see here we have 2 times these rows, okay? We have 2 rows, and the product is 12 is written inside. The question is, well, what would we multiply by 2 to get 12? That's a lot of algebra right there. We're going to be looking for the unknown, and sometimes the unknown can be something that we can define by simply doing our math. In this case, we're looking at 12 as being the area, and we know that one of the sides is equal to 2. Well, what's the factor that we multiply by 2 to get 12? And the answer there is 6. And if you counted the number of 1, 2, 3, 4, 5, 6 boxes within a row, and we know that there's 2 rows which gave us 12, well, we know that the answer at the top is 6. Okay? The result of dividing one number by another is called their quotient. By the quotient of the numbers x and y, we mean the result of dividing x by y and write it as x over y. So when we say, you may be used to seeing something like this, right? The quotient. Well, when we're writing across an equation, we may have used this in the past, and in the same we used also the x to multiply. Well, we are changing things up here in math, aren't we? And we're now expressing a quotient as x over y. Now you might have learned that before as well. You knew that fractions represent division, so we have x over y. The quotient of two numbers, like their difference, depends on the order of numbers. So remember, we said that when you add two numbers or when you multiply two numbers does not matter their order. Well, it matters when you're subtracting, and it also matters when you're dividing. Obviously, if we were to say 2 divided by 4, okay, or 2/4, we know that's equal to, well, that would be equal to, if we tried to factor that, we know that this is 2 times 2. Okay, and you see I use my little dot there, and I would just eliminate this 2. Well, this is 2 times 1, and we have 1/2. Now we know 2/4. If we just took a pizza and we cut it into 4 equal parts and we ate 2 slices, we'd have still 2 slices left, which would be half the pizza. Okay, but now we're saying 2 divided by 4, but what if I said 4 divided by 2? Well, that would be different, wouldn't it? Okay, because if we factored that out also, that would be 2 divided by 2, and this would be 2 times 1, and we're going to factor these out. And I know I'm taking a little bit of a shortcut. If you're not familiar with what I'm doing here, we will be doing a lot more of that in the future, and it's factoring out, but we know we have 2 over 1, and we know that 2 divided by 1 is equal to 2. So there's a big difference when you divide 2 by 4 versus dividing 4 by 2. So two different answers. So remember, the order is very important. The quotient of 3 and 6, 3, 6, for example, is not the same as the quotient of 6 and 3, 6 over 3. When we refer to the quotient of two numbers, we mean that the number that results from dividing the first number by the second number. Okay, so we say the quotient of two numbers, the quotient of 2 and 4. So the quotient of 2 and 4 would be 2 over 4. The quotient of 4 and 2 would be 4 over 2. So the order in which it's given to you is very important. Okay, the first number goes at the top, the second number goes at the bottom. Okay, so we're dividing the first number by the second. Although quotients are found by division, they can be checked by multiplication. So to check that 80 divided by 5. So we have here, let's go into our little bottom corner, 80 divided by 5, okay, is equal to 16. Okay, and we could then multiply 5 times 16. You see that little times there? Well, we're just going to go back and change that, aren't we? We're going to actually use 5, and I wrote it on purpose so you can see. We're going to say 5 times 16, okay, and that's going to be equal to 80. And of course, we could just sit there and do the math. We know that 5 times 6 is 30, and carry the 3, and 5 times 1 is 5, plus 3 is equal to 8, so we would have 80. Okay. In general, the quotient x over y is a number that must be multiplied by y to give x. All right, so let's go back over here, and what they were saying is we have x divided by y, right? And, well, what we would have when we had 80 divided by 5 is what number? We had 80 divided by 5, and that answer was 16. So we know that what is this number? Okay, what is this going to be? Well, if we multiply these two together, similarly as we multiplied them over here, that number, whatever we multiply, is going to give us x. So you can think of division in terms of multiplication as well. Okay, it takes a little bit of practice. You should get very familiar with being able to manipulate the values, and when I say manipulate, I mean that in a positive way. In other words, you can take your expressions and move them around, and it makes it easier. Sometimes you don't necessarily do it on the paper itself, but you can do it in your mind. When I see x over y, when I had 4 over 2 over here, well, what number times 2 is equal to 4? Well, that number is 2. So that's just another way that we can look at division, again, as it is a cousin to multiplication.